You've heard all about the magic of machine learning, right? It's everywhere. In your Netflix queue, your spam filter, even in self-driving cars. But, there's this kind of hidden truth that most people don't really talk about. So get this. For every 100 machine learning models that get built, only about 30 of them ever make it into a real product. Yeah, that means a staggering 70% of all that hard work, all that incredible data science, it just never sees the light of day.
So, what's going on? I mean, why is it so incredibly hard to take a brilliant model from a data scientist's laptop and make it actually work in the real world? Well, it turns out the answer lies in a huge misunderstanding of what a machine learning system really is.
To really get to the bottom of this, we need to look at two totally different worlds, the world of traditional software and the world of machine learning. Now, on the surface, they might seem pretty similar, but trust me, they are fundamentally different beasts. Okay, let's make this real with an example. Imagine we're building a streaming service called Retroflex, and its whole mission is super simple: stream thousands of classic old-school movies to its users. So at first, Retroflex keeps it simple. They make a top movies list using a really straightforward formula, kind of like how IMDb calculates its top 250. It's predictable, it's reliable, and honestly, it's pretty easy to manage. And the setup behind it? It's beautifully simple. You've got a database with all the movie info, a backend that runs the formula, and a front end that just shows you the list. It's this clean, predictable three-step process. But then, there's a problem. People are getting bored of the same old top movies list. Engagement is dropping, so the team decides it's time to level up. They're going to bring in the big guns, machine learning, to create personalized recommendations for every single user. And this is where things start to get messy, like really messy. All of a sudden, you're not just dealing with a simple formula anymore. Now you have to track every click, every pause, every single rewind. You need a massive data warehouse to store all this information. You have to build these complex pipelines just to clean it up. And on top of all that, you have to actually train a machine learning model. The complexity just completely exploded. So what was once this simple, elegant three-part system has now morphed into the sprawling, complex web. The difference is kind of like comparing a bicycle to a space shuttle. They both get you places, but one is just a whole different level of complex. And this is where it gets really interesting. See, in a normal software system, if something breaks, you know it's a bug in the code. But in an ML system, the problem could be in the code or the model or the data itself. And here's the real kicker. Software is predictable. You put in the same input, you get the same output every time. But with machine learning, it's a different story. The recommendations might change from one day to the next thanks to this thing called drift, which is where the model's performance slowly gets worse as the world changes around it. Okay, so we've seen how adding just one model can turn a simple system into a complex beast. But what happens when you start adding more? Well, that's when you enter the chaos of scale. All right, so we've got our first model, the movie recommender, and it's up and running. It's a little bit of a monster to manage, but hey, it's working. For now, anyway. But of course, the business wants more. Now, they want to add a second model for targeted ads. And here is where the real trouble starts. This new ad model, it needs to know what the movie recommender is suggesting. And just like that, we've created our very first dependency. And it's a fragile one. And it doesn't stop there. Now they want a third model to predict when a user might cancel their subscription. Well, this model needs data from both of the other models to work. Do you see what's happening here? We've basically built a house of cards. If the movie recommender starts to drift, it'll throw off the ad targeting, which then poisons the data for the churn model. A single failure can bring the entire system crashing down. And remember, we're talking about millions of users. This is the reality for so many companies. They get trapped in this tangled web of models, and it's an absolute nightmare to manage. But what if there was a better way? A way to bring some order to all this chaos? Well, there is. And it's called MLOps. MLOs, which stands for Machine Learning Operations, is the answer to all the chaos we've been talking about. It's really just a set of practices and tools that lets you manage the entire lifecycle of a machine learning model, from the first line of code all the way to deployment and beyond. Think of it like this. MLOps takes the best of three worlds. From machine learning, it brings the expertise in building powerful models. From data engineering, it borrows the skills to build solid, robust data pipelines. And from DevOps, it takes the principles of automation and continuous improvement. It's the perfect marriage of all three.
So what does MLOps actually do for you? Well, it means every single model you build is version controlled, just like your code. It means that every experiment you run is totally reproducible. It means you can automate the whole process, from training all the way to deployment. And maybe most importantly, it means you can create a system that is constantly learning and getting better on its own. It turns that chaos into a well-oiled machine.
So let's tie this all together. Why does MLOps matter so much? And why are companies like Google, Netflix, and Amazon pouring millions and millions of dollars into it?
Hey, remember that 70% failure rate we talked about at the beginning? Well, MLOps is the bridge that closes that gap. It's what takes a model from the safety of a data scientist's laptop and brings it into the real world, where it has to perform reliably for millions of people 24/7. And if you take away just one thing from all this, let it be this. Machine learning doesn't end when the model is done training. That's actually the easy part. The real work, the real challenge, it begins the moment that model goes live. And MLOps is the system that keeps that whole journey going.